In 1997, several historians and archaeologists got together and decided to try to build a medieval castle using the materials and techniques of the Middle Ages. The style of the castle was to be similar to Château Ratilly, which is close to the Loire River in France. Plans were drawn up by Jacques Moulin based on the plans of a 13th century castle. The castle was to be surrounded by a dry moat with access across a drawbridge. Models were built to show the stages of construction, and the location was finally decided. In order to reduce costs, the castle was located inside an old quarry. The stone used for building the castle is iron-based sandstone, which is obtained from the quarry itself. There are different degrees of hardness within the rock. The hardest stone is used for the outside walls of the building. The softest stone is used as filling between the walls. To quarry the stone, a line of holes is drilled into the rock. Steel wedges are fitted into the holes and are struck with a hammer. The shock wave causes a split to form in the stone along the line of holes, which breaks the rock up. It's then sent to the stone cutters for finishing. The stone cutters and other artisans at the site worked in lodges. These were open-sided buildings built out of wood and held together by wooden pegs. Nails were expensive and were not wasted on temporary structures like these. The roofs were made of wooden shingles, which were fashioned by the carpenters. The stone cutters worked in a lodge which consisted of two parts: a drawing floor surface on one side for preparing the geometrical shapes from the working drawing, and a workshop on the other. A stone cutter could cut on average 4 stones a day for the cladding of the outside wall of the castle. In the Middle Ages, the stone cutter was paid per finished stone. The working drawings of the castle were a full-scaled pattern of the shape of each stone needed. From these, a carpenter would make a wooden jig or pattern. The stonemason could then put the jig on the stone he was cutting to check the exact shape. The stone cutter's tools are a stonework hammer, a joining pin and a chisel. To cushion the shock waves and protect the edges of the stones, the stone cutters rest them on thick braided ropes called torches. Although this stone cutter is wearing glasses, in the Middle Ages there was no eye protection and injuries from chips of stone were common. When a stone was finished, the stone cutters added 2 types of mark to the stone. One was the stone cutter's stamp of approval of the work carried out, and the other was a mark which indicated exactly where the stone was to be positioned in relation to those already laid. Some of the more intricate carving was done by specialist masons and could take days to complete. In order to make sure that the blocks were the exact shape with right angles on each corner, a simple loop of rope was used which had 12 knots in it. This method was developed by the ancient Egyptians when they were building the pyramids. In fact, the distance between the knots is 1 cubit, or 0.5236 metres. Coincidentally, if you lay the loop out as a circle, the radius is exactly 1 metre, a distance related to the circumference of the Earth. Could the ancient Egyptians have known this? The beauty of the rope loop was that it depended on Pythagoras' theorem, a 3-4-5 triangle. They'd stretch the knotted rope out, ensuring 2 sides have 3 and 4 knots respectively. The third side has, of course, 5 knots. When laid out like this, they have a guaranteed right-angled triangle to work with. The benefit of a 12-knotted loop is that it easily becomes a 3-4-5-sided triangle, or a 3x3 square, an equilateral triangle of side 4, a regular hexagon of side 2, and in combinations forms other useful shapes including regular pentagons and decagons. This means these shapes could be formed without having to actually know how to do the construction geometrically. For fine stonework around the windows, the surface of the block had to be very level. To make sure it was even, the mason put coloured chalk on the bottom of his set square and slid it across the surface. If it made a darker line in any one spot, he would chip away at it until it was level. The blacksmith played a fundamental role in the building process. A stonecutter wears out, damages or breaks about 2 sets of tools a day, so the blacksmith therefore spends most of his time repairing or making tools. The iron-based sandstone from the quarry is baked in a kiln for 2 days to release the iron. The pure iron is then heated in a forge, a very hot oven. Bellows are used to push oxygen into the fire and thus make it burn at a high temperature. The iron is put into the fire to heat and then banged into shape with a hammer. To temper or make it harder, it was then dipped into water and cooled rapidly. The blacksmith then reheated it and banged it again until he had the required shape. The blacksmith also makes gudgeons, hinges for the door, nails and tools made of metal. The carpenters were also very important and had their own separate workshop. They were responsible for making all the wooden elements of the castle. Initially they would select the trees to be felled from the local forest and then use axes and wedges to cut them down. When the trees had been felled in the forest, they were hauled away by draft horses. These horses were extremely well trained and often responded to their masters' voices. At the castle site, they pulled carts to transport the raw materials to where they were needed and were capable of very delicate manoeuvring. Once cut, the wood needed to be split into usable pieces, and this was done using chisels, an adze and a double-bladed mortising axe. Like the stone cutters, the carpenters used geometry to draw the work to be carried out on the drawing surface of their lodge. The wooden objects were cut out, assembled and checked in the lodge, and then transported to the final place of assembly. The carpenters were responsible for building all the scaffolding, the doors and any bridge work that was needed. They also made tool handles and moving and hoisting machinery. The hoisting machinery could lift up to 500 kilograms. The carpenters built the bridge across the moat of the castle. It took 3 of them over a year to make, and they used 56 oak trees and 680 forged nails. It is held up by 2 stone abutments at each end and wooden pillars, and half of it can be raised and used as a drawbridge. The masons were the people who actually laid the stones in place. There was a master mason in charge of the site, and he would often have several apprentices. Masons belonged to guilds and were sometimes referred to as the Freemasons, as freestone was the name of the stone that was commonly used. This was because it was soft and allowed the masons to complete intricate carvings. The lime pit was an important part of the building site. Masons used mortar to join the stones, which is a mixture of lime and earth or sand. Due to the slow drying of the mortar, castle walls retained a degree of flexibility. The mortar was made on the ground by the masons' apprentices and then placed in wicker baskets for transport to the area it was needed. The stone blocks and mortar were hoisted into place using a series of pulleys. On average, 6 tons of stones were lifted each day using a large drum winch. A man would get inside the wheel and start walking. As he did, the rope attached to the pulley wound around the axle and lifted the load. The masons used a trowel to apply the mortar to the stones. They made sure the stones were vertical using a plumb line and checked the horizontal line using a plumb line attached to a square. The walls of the castle are much thicker at the bottom than at the top, sometimes up to 6 metres thick. It wasn't practical to make the entire wall of dressed stone, and so an inner and outer wall were constructed, and the middle of the wall filled with rubble and smaller stones. In order to build the vaulted roofs of a castle, some support was needed during the building process. This came in the form of boxing, and the carpenters were responsible for producing this. A framework made out of wood was constructed at the site. The measurements had to be exact as determined by the master plan, as it had to support a heavy weight. The boxed frame was smoothed off and the legs of it supported on chocks to hold it in place. Construction of the vault began with blocks being cemented into place along the ribs of the frame. All the ribs were constructed at the same time to keep the structure symmetrical and the weight distributed evenly. The keystone, which is carved from one piece of stone, is placed at the top of the vault. It is the keystone which holds the whole vault in place. Finally, the vaulted roof is closed as stones are added to the ribs. When the vault was finished, the formwork was lowered by removing the chocks from underneath it. This enabled the masons to see if it would hold up on its own. The boxing was then dismantled and removed from the area. The fine stonework around the windows was left to the master mason. Each stone was placed precisely according to the plan. The spiral staircases in a castle always turn to the right. This makes it difficult for a right-handed assailant to go up the stairs, while at the same time making it easier for the defender, who is also right-handed, but at the top of the stairs. Just before the staircase is a deflector, which slows down assailants and prevents them from passing through with long weapons such as spears. Other defensive features are also built into the castle architecture. All the doors have inverted hinges and so can only be opened by pushing to the right. All the door sills are raised and the lintels at the top of the doors are lowered, so you have to bend to go through the door. The castle included small slit windows to enable arrows to be fired at the enemy without the defenders being hurt. Sometimes a moat was also constructed as a defence. This could be filled with water or left dry. As well as the people actually building the castle, there needed to be a number of support staff, making things the builders needed. Potters would make bowls and drinking vessels for the site, while weavers would make fabrics for clothing. Rope was used as bindings and on the hoisting machinery, so the rope maker was an important craftsman at the site. Rope was made on a rope walk using hemp, which is a plant fibre. The hemp came to the rope walk in bales where it was soaked in water, beaten and then combed into long fibres. The hemp fibres were then gathered and spun to form yarns. Hemp fibres were tied to a hook attached to a wheel, which was slowly turned whilst the rope maker walked backwards down the rope walk. He fed out additional fibres from the supply he carried around his waist. The yarn was then twisted into strands and later twisted again to make the desired thickness of rope. The rope walk method employed a jack or spinner. This consisted of 3 revolving hooks which would turn on a stationary jack. On the other end of the rope walk you had a traveller, a single revolving hook constructed on a simple wheeled device that would allow it to move slowly in the direction of the jack as the strands were twisted and grew shorter into rope. The twist of the yarn is opposite to that of the strand, and that in turn is opposite to that of the rope. This counter-twisting helps keep the rope together. Since a rope walker walked at a measured pace of about 4 kilometres an hour to keep the tension correct, he could sometimes walk nearly 40 kilometres in a 10-hour working day. Finally, there was always a place to eat at the castle building site. Cooks would prepare meals to feed the workers, and pork was raised on site and readily available. Guedelon Castle will take 25 years to complete, but already it has become one of the major tourist attractions in Burgundy, with over 100,000 visitors each year.